whenever you guys are given the sides of a triangle, regardless of what you need to do or so forth, sketch the triangle. Doesn't really matter what your triangle looks like, all right? But graph, get a triangle up there. And I'll just label this A, this B, little b, big C, little c. Okay? Again, your triangle could look totally different from mine, but just make sure it's oblique. It's not going to be a right triangle. We're given A, which is 29.8 degrees. Little a is 28.6 units, and little b is 35.8 units. Now, I know that I need to find the missing sides of the triangle, right? But I can't solve for anything on C because I don't have any sort of a ratio. So the best ratio that I'm going to want to do is ratio with sine with A and B. So I can do 28.6 divided by the sine of 29.8 is equal to 35.8 divided by the sine of B. Okay? Now, I really, really, really hate using cross multiplication or even saying cross multiplication, because the way that I've solved fractions is always I can't solve when I have my variable in the denominator. So I'm going to multiply by my variable on both sides. Right? Now, let's look at what's happening here. If I have this, so now I have, you can think about it like this. 28.6 divided by the sine of 29.8 times the sine of b is equal to 35.8. I basically have a fraction multiplied by sine of b. To undo multiplying by a fraction, you multiply by the reciprocal. I'm showing this step by step so you guys can further now make So now, to solve for b, I need to figure out what this is, right? But again, guys, I'm solving for b, not sine of b. So if I have sine of b and I want to solve for b, what do I need to use? I need to b equals sine inverse. So what I'm going to do is b is equal to sine inverse of 35.8 sine of 29.8 all over 28.6. That's how we solve for b. You have to use the inverse. Okay? So what I'm going to do, go around that way, please, is I am going to hit second inverse, or second sine. So that's telling me to take the sine inverse. And then I'm going to multiply. Then I'm going to put in this product. So I'll do 35.8. 35.8 times sine of 29.8 end parentheses, and then divide that by 28.6. And I get 38 points. Now, there's a problem, though. Wes, question? OK. You could also just do all this together and then take the sine inverse of that. Perfectly fine as well. But, guys, I don't want to round, right? I don't round until the very end, do I? Right? So we don't want to round to the very end. So, ladies and gentlemen, what I'm going to do is this is angle B. I'm going to store this as B so I don't forget it. So what I'm going to do is I'm going to go to stow, which is right below the ln, or right above on. And I'm going to hit alpha B. Hit enter. Now that is stored as angle B. OK? So that's important because now if I want to figure out what angle C is going to be 180 degrees minus 29.8 minus 38.46. So I would say C, so I do 180 minus alpha B minus 29.8. And I get 111.731. Got that, Josh? Okay, now in this case, we worked out all fine. But again, this is the storing feature is going to be very important, especially once we get into next chapter. So I just want you guys, or next section. Now, we have an issue, though. Josh. We have an issue. B is 38.465 degrees. What I'd like you guys to do is let's do 180 degrees minus angle B and see what that gives us. If I do 180 degrees minus B, I get 141.53. Could I possibly, instead of doing 38.4, which we said is our answer, is it possible for this angle to actually also be 141? Could I add 141 plus 29 and it still be a triangle? Yes. So this is what we call case number 1. But watch, if I do C equals 180 degrees minus 29.8 minus, this was 141. Case number 2. I'm gonna store this as D minus 29.8 minus alpha D, and I get 8.66. So the problem is 141.531, C equals 8.669. Case number 2. Okay? So you guys might be thinking, okay, what just happened here, right? This is like something just got totally changed. We are all fine. You find the missing angle, you use the law of cosines, and you find it. The only difference here, guys, is we're using inverse trigonometry, right? You guys see the difference between this problem and the last problem is we had to use inverse sine, correct? Do you guys see the difference? Remember, look at the unit circle, guys. Is there two angles? Here is the sine is equal to some value. Like, for instance, sine of 1/2. Are there two angles when sine is equal to 1/2? Yeah, there's two angles, pi over 6 and 5 pi over 6. So remember, when we're using inverse trigonometry, you have a possibility of two cases, right? You have a possibility of two cases. Now, for some problems, we restricted those cases based on finding the inverse. But on a triangle, sometimes we can create two different triangles. Sometimes we cannot. So the way to determine if two cases is applicable or not, what you need to do is you find your angle. Everybody should be able to get to here. Then, to test if there's a case 2, all you need to do is take your angle and subtract it from 180. Okay? If this angle plus your original angle is still less than 180, then you have a second case. So now what we have is two triangles. We have two triangles. We have a possibility now of two triangles, two cases that it could be. And I'll show you, I'll explain, I'll kind of look at this. Now, the fortunate thing for us is the value of C still remains the same. The only difference is the angles are different. Because look at, here, I figured out that angle. So 180 minus that gives me C, which is 111 degrees. That's my obtuse angle. Or if I change it to 141, this angle, if I subtract 29.8, which was given, minus that, I still get a different angle, which is 8.669. So there's two possible angles for C. There's two possibilities. Now let's just go ahead and figure out what C is. So that's your case 1 and that's your case 2. Last but not least, guys, we can figure out what C is. And again, I can use C. You could use case 1 or case 2. It actually doesn't even matter what it's going to equal. So let's just use case 1 to figure out what C is. So the angle C. Sorry, angle C. Yeah. I'm gonna show a visual representation in just a second. I'm just gonna figure this out, and then I'll show you guys what it'd look like. Okay? I'll give you guys a visual in just a second. But if I wanted to figure out C, I would do C is over to sine of 111.731 is equal to, let's use A, 28.6 over sine of 29.8. C equals 28.6 times the sine of 111.731 divided by the sine of 29.8. So what I could do here is just take 28.6 times the sine of 111.731. But in reality, guys, didn't I save this? Didn't I save this original angle? Right? We don't really want to round. We want to keep that saved. That was the sine of alpha C. And then I am going to divide that by the sine of 29.8. And I get 47.81. As I round it. Now, does that look right for my triangle? Yes. OK. So you guys, again, I know I kind of threw this at you, and you're looking at it.